demonstrating to you how to import a DXF wireframe into SAP 2000. So this is a little bit of a trick that actually made my life very easy when it comes to structural analysis. As a structural engineer, SAP is an extremely powerful tool, and especially if you know how to use AutoCAD with it, it can make your life much easier than what you think. But the thing is that if you dedicate yourself on internet research like I did, then you're probably up for a really strong disappointment about the information that's actually publicly available. So to start with, you have your wireframe designed on AutoCAD. So let's just assume that this is just a building with the base. Now I will be adding some areas to this and some points, but first of all let me start with frames. So to be able to import things into SAP 2000, you need to break down things from AutoCAD into layers. So you can see here that I've got already 2 layers made. If you don't, you just click on new layer and just make them. It's very important that you assign every single thing to the layers that you're really interested to. So all these wireframes that I'm using here, I'll just assign to the frames. Now, just for the demonstration purposes, I'm going to be assigning a lot of points to this so that I can show you how to import that. And I'm also going to be assigning some areas to the base and perhaps the roof so that I can show you how to simulate a foundation as a solid or a roof as an area on top of your structure. So if I get rid of frames, there you go. I've got my points and they're in the correct layer as well. So now I'm going to just make frames visible and I'm going to make a new layer which I'm going to call 3D faces. Now this layer I'm going to make red. Doesn't really matter which color you make it as long as you know what you're doing. So the first command that I'm going to throw in AutoCAD is 3D face, and I'm just going to assign a 3D face on the top here. That's going to simulate my roof. Now I'm going to select that and I'm going to throw it into the 3D face layer. Now for the foundation, you can do it on a 3D face, but because I'm interested into actually making it into a solid, it's better if you use a more solid command and then convert that into a 3D face. So for what I'm doing here, I'm assigning a rectangle to it. You can do it with a polyline, no problem, as long as it's closed lines, because now it's the point where you're going to throw a 3D face into that. The reason why I did the rectangle at the beginning is to just show AutoCAD and SAP that there's actually there and those are the limits. Let's throw that in 3D faces. Now let's get rid of that. See, there you go. So there you go. This is the structure that we have and we're ready to import into SAP 2000. Before we do that, we need to export, save this. On the desktop, I'm going to save it as a SAP 2000 frame and it has to be a DXF format. I haven't tried every DXF format here, but I know that 2010 and 7 work flawlessly for me. So I'm going to go for a 2010. And I'm going to save that. I'm going to replace what I've already got on my desktop. And now let's transport this into SAP 2000 and see how we assign the layers. One more thing that's very important to remember. You need always to remember your Z direction where it is. So in terms of Z direction, I mean the direction that is up. That direction may be Y or X depending on how you decide to orientate your model axes. In this case is Z, so you just need to remember which way is up and the units that you're using. So let's just move on to the small machine that I've got right next to me at the moment and run the simulation on SAP 2000. Okay, so here we are now ready to import the DXF file that we have previously created on AutoCAD into SAP 2000. So the first thing that I want to do here is go to File, Import, and then go to AutoCAD DXF. You need to find the file where you saved it. For me it was on the desktop, so I'm just going to go ahead and open that. My up direction was Z and the units that I would like to use for this simulation is kilonewton meters. So I'm going to assign now my layers to it. Now a really good point Special joints are usually the points that you're using, but if you want to simulate the points that you previously designed on AutoCAD into springs or other links with special properties, then you should assign those to ML links. The frames go to frames and the shells go to 3D faces. So if I just throw that in, you can see now that I've got a 3D model of exactly what I've been designing on AutoCAD. So you should note that I've got two areas here. Both of them are concrete. One of them is going to be my foundation and the other one is going to be my slab. So let's just start assigning members to that. So first of all, I'm going to assign an area section to the slab, and I'm going to name that concrete slab. I'm going to assume 4000 psi concrete, and I'm going to make the bending membranes be, the thickness generally be 20 centimeters. You can see that it's assigned there to both. You don't want that because you're going to go through the solid face for the foundation. So let's just get rid of the foundation assignment for him. Second thing you want to do is divide your areas into finite elements. So to do that, you need to choose your areas and go to edit your areas and divide areas. You can make your areas more symmetric and be the boss here and make the decision on how you want to make it, but because I don't really care at the moment how fine I'm going to make my mesh, I'll just let SAP decide it for me and give it a minimum thickness of 1.2. So the second thing you want to do is check that the area on your actual roof is assigned. To do that, you need to make sure you can see the extrude views, and there you go, you can see the thickness of your roof. Let me just get rid of that. Now I would like to convert the foundation into a solid. So to do that, I choose the foundation and then I go to edit, extrude, and then I need to extrude my areas into solid. So I choose this command right here. Now there's a few things to note here. First of all, we need to add the material that we want. So I'm going to call this foundation and assume a 4000 psi concrete. Hit that OK, and assign my foundation. Now you've got two choices, two things to worry about here: the plus 3D thickness and the minus 3D thickness. The minus 3D thickness is inverse to the plus one. So if you assume that your axes are right here, if you give a 3D thickness of 1 on the minus direction, this means that it's going to go up, and if you give it to the positive direction, that means it's going to go down. So for this simulation, I'm going to be assuming 0.5 the thickness of my foundation to the down direction, and I'm going to give it 0 from this point, from this line here up. Now this might have confused you a little bit, but hopefully now as I click OK, you're going to see exactly what I mean. So as you can see here, let me just zoom in so you can exactly get what I mean. This is the point where my foundation is 0. If you have a look at here, my Z is 0, and this is where my Z is minus 0.5. So the plus direction in the conversion between an area to a solid assumes the minus actually direction to be the positive. Now I can assign frame sections to it, which I'm just gonna go through and do really quickly. I'm going to assign sections from the AISC table. I'm not going to go through assigning different sections for the beams and the columns, like universal columns and universal beams, but in reality you should do that because beams and columns are different sections. So let's just go through the DS shapes. DS means the British standard shapes, so for this I'm just going to assume a random section throughout. That might be a little bit big. Let's go to the small ones. 203, yep. So that's my section, and let's just throw that in everywhere. Now let's have a 3D view of what we're actually doing here, and this is what my structure actually looks like at the moment. Now one thing that I haven't done is assign restraints between the foundation and the ground. Depending on the ground and soil conditions that you're going to be using, that's totally up to you, but however for this simulation I am going to be using fully fixed connections to the ground. So to do that, I'm going to the XY view, and you can see that I'm looking at the roof right now. And if I click my down arrow, you can see that it changes my views. So now what I'm looking at here, if you can see right here, what I'm looking at is Z equal to 0. So this is my foundation, and I'm going to go assign join restraints and make that fully fixed. And as you can see, the fully fixed connections are now put on there. I trust that you know how to assign loads to your structure, so I'm not going to go through that, and I'm going to just run a live model so that we can actually see how this performs. I'm going to just name that as a test and wait for the simulation to be done. And there you go. That is your deflected shape for this structure. Hope you enjoyed this video. If there are any questions, please do not hesitate to post them here. I would like you to private message me for any private matters or any questions that you would like to ask me, or videos that you would like me to do, but just put them on the comment box in the video so that more people can actually see your questions. So this is it from me right now. This is Mike from EngineWorks. Thank you very much.